on the shark bite, which numbers do we want to see? Go over, have questions about? One. Okay. And I was Aaron. Three was a little challenging. I didn't mean to make it that hard. They were supposed to work out nicely and they did not. Any others? Alright, so starting with number 1, translating the statement 5 times. So we're going to have 5. Because it's multiplying to the difference of, I need parentheses. You are subtracting the number, pick whatever variable you want, i.e. x and 3. And then is 17, that would be equals 17. So 5, then parentheses, x minus 3, and parentheses equals 17. Questions on that one? And 3, I'm going to show you in Desmo so you can see what the answers would be graphically, and then we'll pick one of the methods, either elimination or substitution, to do. Could someone read me off one of the equations? 2x plus y equals 6. 3 is my done. Okay, and then the other one? X minus y equals 5. Okay. So when these two cross, you get decimals. So not nice numbers like I wanted to see. So if you graph it on Desmos as you can do, those would be your answers: 2.43, let's say we run into 2 decimal places, negative 1.29. So I'll write those down, but then I'll also write down the answers we get when we do it algebraically. I already forgot this one. 4.3. Negative 1.2. Substitution would probably work the best, but you could have done elimination also. Did not matter, your choice. But if you did graphing, you didn't have to do this. So this is like extra. So let's say we did substitution. You could either solve for this x or this y. Either would be easier to solve for. Let's say I did it for this one. Got rid of 3x. And then I would take this piece and put it in where y is of the other one. This should be x. So like I have 2 variables, but you only have 1. Then I could distribute. Combine my like terms, get rid of the 12, and then divide both sides by 7. So if you had graphed this, and then you did this by hand, you could put this in and it should match the decimal. So 2.42, it only showed me a few, but it is that number. And then I would put that back in to find my y value. The easiest one to put back in would be the one I already solved. So y equals negative 3 times 17 over 7 plus 6. negative 51 over 7 plus 6. And negative 9 over 7 would be your fraction, but if you change it to that decimal, you get the same thing that we got before. So you would either have this as a decimal or this as a fraction. Both are technically right. Other questions on the shortening? If you have not already, go ahead and pick out your notes from last class. The ones that look like this. But then find this page. So we talked a lot about different transformations last class. Today we're gonna summarize those, but also start to think about them in a different way, so that we're going away from comparing the graphs and being able to look at the words and know what they mean, know what it does, what that would look like when you write it as an equation. So there's going to be a lot of writing for this part, and then we'll talk about the features of the graph. So for vertical, that's our up and down things. Those affect the y values. And I'm going to put a little side note that'll really help us later. Right now it won't really make much sense. But those will be things that are outside. So then horizontal would be opposite. Left to right. Those would affect your x values. And those will be things that are inside. So then we talked about a bunch of different transformations. We're just going to list out the different vertical and then horizontal things. So we talked about shifts. There was a vertical shift that moved up and down. There was a vertical reflection that flipped it over the x-axis, flipped it upside down or over the x-axis. So that wording is a little weird because x-axis, you're usually thinking x values, but if I'm saying it flipped, you're not going to that word. There's flipped in there, but it is really small. If it flipped over the x-axis, your y values are changing. And then the other two were vertical stretch and vertical compression. So I'll write those up here, but then the bells and everything, then we'll finish up and come back. For a vertical stretch, it gets vertical compression gets wider. And then we could say the opposites for the horizontal. We talked about horizontal shifts and how that moves left and right. We talked about horizontal reflections that flip over the y-axis. So that one is weird again because it says y-axis, so you're thinking y values. But if you have your y-axis and you're flipping over it, your x values are changing. Then we didn't talk about these next two, but I'm going to write them, and we're going to talk about what it looks like. A horizontal stretch and a horizontal compression. And you would think it does the same thing, but if you think about the horizontal things in general, they do the opposite. So for a horizontal stretch, it gets wider. And a horizontal compression gets narrower. And you're going to see why that is here in a moment. So for each of these transformation words, translated, reflected, stretched, compressed, we're going to draw like a rough sketch of what those would look like for each type. So I'm going to draw in two axes for translated. If you want to do this for all of them, reflected, stretched, compressed, you could do that, or wait till we get there, either or, doesn't matter. And I'm going to label one V and one H. So translated is another word for shifts. We used the word shifts last class, but you may also see the word translated. So interchangeable. If we translate or shift it vertically, it either moves up or it moves down. So let's say I'm using the quadratic parent function, our U shape. Instead of it starting at the middle, it would either go up or it would go down. And I would just show that it moves up and down. That's all the point of this part is, just to kind of focus, put all those words into pictures so we can kind of put them together and compare. Then the horizontal translation or shifts moves left and right. So if it was at the middle and moved to the right, it would be somewhere over here. And then if it did the same thing to the left, it would be somewhere out here. And I would show that it's moving left a little bit. I'm going to put a side note like at the bottom to say that translated is the same as shifts. Questions on that so far? This part isn't really new, it's just summarizing what we've already done again, but in words and not in pictures. So then once you have those drawn, go ahead and do another two axes for reflected. And label them V and H. The vertical reflection set is flipped over the x-axis, so if it normally faces up, now it's facing down. So it's been flipped upside down. It's what the second set of arrows are trying to show. The horizontal reflection, unless it's been moved, like horizontally shifted or translated, it's going to look the same, but it's shifting around the y-axis. I'm going to put a side note for the horizontal that it has to be shifted before it can be seen. Questions so far? Then stretch, we're going to do the same thing. So we talked about vertically stretching something. It's stretching towards the y-axis, so it gets narrow. So try to draw yours a little bit narrower. And then I'm going to draw arrows inside of that to kind of show it's going towards the y-axis. So do that to the best of your ability. And then I'm going to write that as a side note. It's stretching towards the y-axis. So it gets narrow. The horizontal will do the same thing, but towards the x-axis. It's going to stretch towards your x-axis. So as it's doing that, it's going to keep getting wider. So it will look something like that. And it's stretching towards the x-axis. So then this gets wider. Questions so far? And then we're going to draw the last two for compressed. And we talked about vertically compressed, how it's kind of going away from the y-axis. We can say it's shrinking away from the y-axis, which is why it gets wider. I didn't draw it as wide as the horizontal. I'm trying to prove different points, but you could have that be fine. So I could say this shrinks or compresses away from the y-axis. the horizontal compression does the same thing. It shrinks away, but from the x-axis. So if it's shrinking away from the x-axis, it'll start to get narrower because it's getting away from the y-axis. So then that would be shrinks away from x-axis. And then it gets narrow. So we're going to practice some problems where we're going to be given different transformation descriptions, and as we see those, we have to be thinking of these pictures in mind, like what happened to it, where did it go, what did it do, in order to write the transformations into an equation. Before we do that, there's an equation on the very last page at the top. I'll go back. We're going to write this in this practice piece. So you can write it y equals or f of x equals either or. And the one that was on the back was a, then in parentheses, x minus h squared plus a. This is the format that all of our equations will be written in. You may remember this when we were doing quadratics as your vertex form. So when earlier I said that the vertical things are going to be outside and the horizontal things are going to be inside, it was really referring to this. So if we know what the transformations are, if they're vertical or horizontal, then we can figure out where they go and start to write it. So let's start. In number 1, the f of x equals x squared, that tells you what your parent function is. So which function you need to use when you write it out. We're only going to be using 2. Like I said, there's a bunch, x squared or the absolute value of x. So, but it is good to know that this is your parent function. And then we need to find transformation words. So any of the words that we talked about before, translated, or it may say shifts, reflected, compressed, stretched. Do you see any of those words in this? Translated. So I'm going to underline this for now. On top of it, I'm going to write shifts, because we need to know that those are interchangeable. And there are 2 types of shifts going on, 4 units down and 4 units to the right. So would 4 units down be vertical or horizontal? Vertical. Would 2 units to the right be vertical or horizontal? Horizontal. So since vertical things happen outside, ignore that. So this would be outside. Horizontal things happen inside. So on the outside of this function, it's either going to be a or it's going to be k. And then on the inside, that's where your h is. Now this h and this h are 2 different h's, but they're related. So we would start writing this like the beginning, f of x equals. Our a value would be if we had any vertical stretches or compressions or reflections. Do we have any of those things? Vertical reflections, vertical compressions, vertical stretches. Do we have any of those? see those words somewhere? Vertical stretch, vertical compression, vertical reflection. No. That means we don't have an A, or our A does not change. You can leave it as 1, you can put the 1 or don't, it does not matter. The X in this will always stay the same. Because we have something that goes on the inside, 2 units to the right, this is why it does the opposite. Because you want to put a plus, because it's positive, but because the format already has a negative, it becomes negative. So it's always going to be the opposite of what you think. If it's to the right, it's negative. If it's to the left, it's positive. And then on the outside, 4 units down, is whatever it says. It doesn't have to be plus, it could be minus. So how would we write down 4 units? Minus 4. We have both of the transformations, and that would be our answer. Before we go to the next one, what questions do we have on that? So then in the next one, I again see that this is our parent function. What transformation words do you see? Reflection, compression, translation, shift. But yes, you said reflected. What transformation words do you see? Reflected. And I'm going to underline the over the x-axis. That's going to be important for when we figure out which type. Are there any other transformation words we see? Translated. And we know that's to the left. So reflected over the x-axis, you can look back at your summary, look back at your pictures, or you can picture it yourself. If this is my x-axis, and I'm reflecting over it, is that a vertical or a horizontal transformation? Vertical. And then translated 7 units to the left, would that be horizontal or vertical? So moving to the left. So then your vertical is always outside, horizontal inside, and then we can start to write our equation. Start with our f of x. We have a vertical reflection, so that is going to go where A is. But the reflection is just a negative. So if you were putting the 1, this would just make this a negative 1. How would we write 7 units to the left? You think that, but it's always the opposite because of this negative. So plus 7. Then do we have a k value that we can put up there? It didn't say anything about translating up or down, so we don't have a k value. The biggest thing with this is don't add in extra things, only do what's there. And that will keep you up. So before we move on to 3, what questions do we have on 2? these words got switched. So on number 3, this should be stretched. And 4 should be compressed. I'm also going to write, our parent function has changed. So I'm going to rewrite our format with our new parent function in it. It'll really look the same, except for it won't have the square, it'll have the absolute value bars. So as long as you know it looks very similar, it just doesn't have the square, you should be fine. So what transformation words do you see in number 3? You're looking for words that say translated or reflected or stretched or compressed. Do you see any of those words? Stretched. And what's nice about this is anytime it's stretched or compressed, it has to say by what type. Otherwise, you wouldn't know where it goes. So it says stretched vertically. And then it also says by a scale of 4, so it tells you by how much. Any other transformation words we see? Reflected. Over the y-axis. So since this is stretched vertically, we know it's vertically already. Is that going to be an inside thing or an outside thing? Outside. And then reflected over the y-axis, you can either look back at the summary, look back at your pictures, or picture it. If this is your y-axis and it's reflecting over it, is that a horizontal or a vertical transformation? Horizontal. So if that's horizontal, would that be inside or outside? Inside. So then we can start to write our equation. F of x equals the stretched vertically, that number is going to go, that is your A, so you're going to put that outside first. Do we have any horizontal shifts that we need to add in? Were there any horizontal shifts? No. So the only thing that's going to go in is your x and your reflection, so your negative x. Is there anything else we need to add? No, that's it. So this would be your equation. What questions do we have so far? And then for the next one, what transformation words do you see? It is compressed, and it says vertically. Also says by a scale of, so we know by how much. Any other transformation words? Translated and the of. Okay. So this already tells us it's vertically, so is that inside or outside? Would a vertical compression be something on the outside or something on the inside? And then if it's translated up 14 units, would up be vertical or horizontal? Vertical. So would that be inside or outside? So then as we're writing our equation, f of x equals, we have our vertical compression, so we're going to put that as our a value, 1/2. Do we have any horizontal transformations? No. So the only thing that's going to go inside is x. And then how would we write up, translate it up 14 units? It's going to be exactly what it says. So yeah, plus 14. What questions do we have on that one? On the back of this page, there are practice problems. I want you to do these 5 problems. After you do that, get Ms. Carson or I to check it. Then you can work on Khan Academy, retest work, finishing tests. But you must do these 5 problems first. So get those done, and then you can work on other things, but make sure you're using this time wisely.